Welcome to our presentation on heritability and repeatability. I'm Hilary Panato,
Hi, I'm Mackenzie Hatfield.
and you'll be learning from Luna and Bucky. Hi, I'm Luna, and I'm going to have an introduction to heritability for you. Heritability indicates the degree to which the variations in animal performance are attributable to the genetic inheritance. This basically means it measures the degree to which offspring resemble their parents in performance for a trait. Heritability measures the strength, consistency, and reliability of the relationship between phenotypic values, observed performance, and breeding values for a trait within a population. Some key information to remember: when a trait is highly heritable, the performance of an animal tells a lot about their breeding value. When heritability is low, an animal's own performance is not a good indicator of its breeding value. And mathematically, heritability is the square of the correlation between phenotypic value and breeding value. It is always positive and ranges from 0 to 1. Heritability and selection. Selection is the process of choosing animals with desirable traits to reproduce, aiming to enhance these traits in future generations. Some examples: efficiency. Traits with high heritability respond better to selection because genetic factors strongly influence these traits. In breeding programs, they use heritability estimates to predict genetic gain and plan breeding strategies. An example of this: if a trait has a heritability of 0.5, half of the variation in that trait is due to genetic differences, making it a good candidate for selective breeding. Some important facts: if a trait is more heritable, then there is a faster rate of genetic change, and phenotypic information leads to the selection. Heritability and management, heritability and prediction. Heritability indicates how conservative a prediction should be. You can use heritability estimates to develop models that predict the breeding values of animals. Higher heritability leads to more reliable predictions of an animal's performance based on its genetics. So, leveraging heritability estimates enhances the precision of breeding value predictions, leading to better selection decisions and improved animal populations. Heritability prediction. In prediction, producers can utilize heritability to affect the outcome of a population when heritability is high by using it in selection. When it's low, management can improve this performance. Breeding programs use heritability estimates to select animals with desirable traits, aiming for genetic progress in future generations. A quick example. For my example, I'm using Siamese cats to show heritability in action. Siamese cats, known for their distinctive appearance and vocal behavior, are also subjects of genetic studies to understand various heritable traits. Coat color and pattern. Heritability is high, 0.70. Coat color in Siamese cats is largely determined by specific genes, which makes it highly heritable. Body weight. Heritability moderate, 0.40. Body weight is influenced by both genetic and environmental factors, which results in this moderate heritability score. Vocalization traits. Heritability low to moderate, 0.20 to 0.35. While there is a genetic component to their vocal behavior, environmental influences also play a significant role. Longevity. Heritability low, 0.10 to 0.15. Longevity is affected by numerous factors, including genetics, diet, healthcare, and environmental conditions, leading to this low heritability score.
Hey, Bucky here. So I'm going to be introducing repeatability. So repeatability is a measure of the strength of the relationship between repeated records, so repeated phenotype values, for a trait in a population, and single performance records and producing abilities for a trait in a population. It can demonstrate the reliability of an animal's performance early in its life, and it could also demonstrate the correctiveness of an animal's performance at the start of its life. So mathematically, it's R equals R, P1 and P2, or R equals R, P, and PA. Okay, so repeatability and traits. So repeatability is based on features that can be duplicated. Here are some characteristics that may be measured during an animal's life. So for highly repeatable traits, this would be consistent with growth rates and mature body weight in livestock, wool and milk production, and performance time. So for non-repeatable traits, it'll be like health status, behavioral traits, and eye color and coat color. So like the examples above, there's like eye color and then there's the milk production. Okay, so for example, for repeatability, so by analyzing several recordings, we can predict how an animal will behave throughout its life. So here's an example of how repeatability occurs based on phenotype value, producing ability, and temporary environmental effect in this example next to it. So, in high repeatability and can be beneficial for achieving specific breeding goals, but there is risk that will occur. So that would be in reducing genetic diversity, inbreeding risk, and lack of adaptation. Adaptability. So ways to improve heritability and repeatability. So 1, make the environments uniform as possible. So provide each animal with same attention and opportunity as the rest of the herd or pack. And lastly, obtain accurate measurements, so collaborating with the scales, and no buildup of feces or debris on the scales.
This was our presentation on heritability
and repeatability.
Thanks for watching. Hope you
Bye.
enjoyed.